What's going on, everyone? Welcome back. Patrick here. Moving on to the next question with infinite limits. We got to find the limit as x approaches 1 from the positive side of this function, ln of x squared plus 2x minus 3. So the quick way to do this, the quick brute force way, is to plug in a table or make a table of values with x values that are really close to 1 but from the positive side. So that's what I'm going to start the video off with, and then I'm going to finish off the video just talking about this function in a little bit more detail so you get a clearer understanding of what is going on. So if we plug in x values close to 1 from the positive side, so let's do like 1.1, 1.01, 1.001. If we take these, plug it into this function, you'd end up getting negative 0.89, negative 3.22, negative 5.52 if you round these to 2 decimal places. And so you could tell that the y values are going towards negative infinity. And so the answer to this is just negative infinity. You could see that from the table of values. Now, here's a question for you. Why couldn't we just ask for the limit as x approaches 1? Why did it have to be from the positive side? Well, first off, if we plug in 1 here, notice that we'll get 0 in the bracket. We'll have 1 squared plus 2, which is 3, minus 3 is 0, and then ln of 0 is undefined. And so we know that at an x value of 1, there's going to be a vertical asymptote. So if we did get a question like this, we would have to approach it from the positive side, which we know it's negative infinity. We see that from the table of values. But what if we approach it from the negative side? What's going to happen then? Well, notice if you start to plug in values that are close to 1 but from the negative side, so like 0.9, 0.99, 0.999, for the x values, you would get an error in your calculator. It wouldn't work. And why is that? Well, let's do a quick little review here of ln x. Now, ln x, we know, looks like this. And we know that the domain for ln x is that all the x values have to be greater than 0. Well, it doesn't just have to be x here. We can have any expression in that bracket. So we could either have an x or we could have an expression like this, x squared plus 2x minus 3. And the domain is always going to be whenever that expression is greater than 0. Because if that expression here is going to be negative, we can't ln a negative. Or if that expression is going to be 0, we can't ln 0. So this expression always has to be positive. It always has to be greater than 0. And so notice that this expression, x squared plus 2x minus 3, when is it going to be greater than 0? Well, this here is a parabola. Notice that it factors into x plus 3, x minus 1. And so if I was to graph this, we would have an x-intercept at 1, and then an x-intercept at negative 3. And it would look something like this. So notice that if we approach this 1 here, which is what we're doing, we have to approach it from the positive side because that's when that function is going to be positive and then defined for ln of that function, if that makes sense. We can't approach it from the negative side because if we plug in 0.99 into this function, we're going to get a negative y value. And so we can't ln a negative number. And so that's why this limit here has to be as x approaches 1 from the positive side. This limit here does not exist if we approach it from the negative side. Or if we just approach 1 in general, because if we're approaching 1 from the positive side, it goes towards negative infinity, and from the negative side, it doesn't exist. It's not approaching that same value in general. So the limit as x approaches 1 of this function would not exist either. Only this one-sided limit exists, and it's because of this. And it's because that expression inside that bracket always has to be greater than 0, whatever it is. We could have also took this function and approached -3 from the negative side over here, that would have gave us -infinity as well. But if we approached -3 from the positive side, so from this way, notice that, for example, -2.99, that would give us a negative y value, which would make this entire bracket negative. We can't ln a negative. So this limit here, it does not exist. And the function that I'm dealing with is this same function over here. Okay, so thought I would mention that, just wanted to go a little bit more into detail about this function. And just remember, whenever you have ln of an expression, the domain is always, that expression has to be greater than 0. In fact, if you were to graph this, the way this function would look, let's graph it over here, is there would be a vertical asymptote at an x value of 1, and then a vertical asymptote at an x value of -3. And it would look something like this. It would almost be like two ln functions going outwards like that. And there would be nothing in the middle over here. Okay? So, and there would also, these would be vertical asymptotes. So at those x values of 1 and -3, that would be undefined. So the domain x has to be greater than 1, x has to be less than -3. And that's why with 1, we had to approach it from the positive side. And then if it was -3, we would have to approach it from the negative side.